Hello, students. Welcome back. So, in this session, we are going to be talking about A B testing. So, A B testing, another name for that is split testing. And what it is, it's a controlled experiment. And we use this to compare two versions of something. And we try to determine which one of the product, okay, which one performs better based on the real user behavior. That's the idea of your A B testing. This concept is used in your data science, when you're designing products, when you're doing marketing, even in AI system. And the idea is this right here. You show version A. Let's say this is your version A of your product and you have a version B. So you show version A to one group of users. Then you show version B to another group of users. And then you measure. You try to figure out which one of these versions is doing better job using data. That's what you do. So let's take a look at an example. Suppose you design a website. So you have a website without a chat part and you have a website with the chat part. And you have two versions. Let's say version A, version B. This is your version A right here. This one says Loxford Academy building a better future. That's all it says. The second one, this is your product B right here. This one says Loxford Academy building a better future, but it also has a chat part right here. Now, so the version A, the one that does not have a chatbot, the without chatbot, let's say it gets 1000 users. Out of the 1000 users, let's say 80 of the people they make purchases. On the other hand, on version B, the one that is using the chatbot with chatbot, let's say it also has 1000 users. In this particular instance, let's say 120 people make purchases. So your conversion rate for your model A, for your version A is 8%. 80 divided by 1000. Likewise, for your B is 120 divided by 1000. So it's 12%. So clearly, by looking at these numbers, you can see that your version B, it performs better because this one has a better conversion rate. So now let's take a look at another example from machine learning. Suppose you build a new machine learning model that actually used for spam detection. So now you have two models, model A and model B. Your model A, which is your control model, this is your old production model. This is the model that you were using before. So let's say we were using logistic regression. And then you have model B. This is the variant. This is the new model that you just came out with. Let's say this could be a transformer, this could be XGBoost, this could be any model. So now you have two group of users, A and B. So 50, let's say you receive email. So when you receive emails, 50% of your emails you are going to send to model A. Okay, this is your old model. The rest of the other 50%, they are going to go to model B. That would be right here. So this will be your user A. They are going to experience model A, and the user B, they are going to see model B. Now, the metrics that we use over here is we use spam detection rate, false positive, user complaint, email open rates, because in these cases, business metrics matter. So, what exactly is a spam detection rate? Well, it measures how good you are at catching spam. Then you have false positive metrics. This one actually avoids. The reason you want to use false positive because this avoids blocking your real emails. Also, for user complaints, the reason you want to use user complaint because this tells you the real satisfaction of the users. Also, the email open rate, you want to use that because it tells you the downstream impact. So let's say you deploy these models, model A and B, and these are the results you obtain after 1 week. So let's say your accuracy for model A is 92% and the accuracy for model B is 94%. Okay, your false positive rate for model A, let's say it is 5%. Well, for model B, the false positive rate is 2%. This is important. For business standpoint of view, this is more important. User complaints. Model A has 120 user complaints, 45 in model B. Spam detected, 8,000 spams were detected. Over here, 9,300 were detected. So clearly, your model B, it actually does a good job in detecting spam. So this actually improves your real outcomes. So in hindsight, now we are going to deploy model B to 100% of the users. So how does A/B testing works? So now I'll show you the step-by-step process. Step number one, first you define your goal. So for example, your goal could be that you want to increase your sign up rate, or maybe you want to improve the click rate, or maybe you want to reduce the bounce rate. Bounce rate means the users, they're coming to your website and they're leaving immediately. So let's say this is your website A and this is your website B. Website B contains chat part, and website A does not contain your chat part. Step two, now you create a hypothesis. So, for example, a hypothesis would be having a chat part is going to increase your conversion. So, that's your hypothesis. And then you split your users randomly. So you have group A and group B users. Your group A, they are going to see the old version of your website, the one without the chat part. That would be this right here. Then you have group B, they are going to see new version of your website, the one with the chat part. That would be this website. Now, in this particular instance, your randomization is very important when you create these samples. Step number four, now you run your experiment. You collect data for sufficient amount of time. So maybe you run this experiment for maybe 1 day or 3 days or 1 week or 2 week, depending on your business. And then you analyze your result. So you could be using statistical testing. You could be using t-test, z-test, or chi-square test. Now, the statistical concept behind A/B testing. Now, A/B testing, it relies on hypothesis testing. So you have two hypotheses. You have null and alternative. Your null hypothesis would mean that there is no difference between A and B. Your alternate hypothesis, this could mean that your version B, that would be this version, is better than version A. That's your alternative hypothesis. So what you do, you check a p-value. If your p-value is small, you actually compare that against the alpha. You define your alpha. If your p-value is smaller than alpha, then you are going to reject your H0. In other words, you are going to say that there is statistical difference between A and B. And finally, you make the decision. You choose a version that shows statistically significant improvement. So if you believe this is better, then you choose this one. If you believe this is better, then choose this one. Now, some of the real life use cases would be in e-commerce and apps. For example, in the e-commerce, you may have a product page layout. So let's say this is the page layout. This is my first one right here. This is the original one. And then I change it to something like this. So this is my A and this is my B. And I check which one does a better job. This could be another example could be pricing display or checkout flow. In the case of apps, maybe you're trying to check which UI design is better. What about notification timing? Maybe you check that too. You can also check for feature rollout. So you can use these types of, these are some of the real life use cases. Another one would be in email marketing. Maybe you change subject lines. Maybe you change the email design by changing these sending times over here. By changing these three things, you can determine whether it improves your business metrics or not. In the case of machine learning, maybe you compare two models in production. Try to see which one of the two machine learning model gives you a better result. So, why is A B testing so powerful? Well, you are making data driven decisions and you are not guessing, you are removing guessing. That's what's happening over here with A B testing. Also, it improves product scientifically. Now, the key business metrics that is used for web pages, just to show you an example, would be conversion rate. For example, this means percentage of users that complete action. So they come to your website and they buy product. They look at the product, they scroll up and down, and then they buy the whole product. They do the checkout and they make the payment and everything. So that's your conversion rate. Then you have CTR, which is called click through rate. Then you have bounce rate. Bounce rate means user leaving immediately after visiting your website. Revenue per user, this is what you want to do. Like this, actually think of this as a business impact, like how much revenue each user is generating. Engagement time, like how much for how long did the user stayed on your website. In other words, this shows user interest. Now I will show you how to do A/B testing for machine learning model deployment. First thing I'm doing, I'm importing necessary libraries. I'm importing NumPy, importing Pandas. I'm also importing scikit-learn because this is the one I'll be using to create the model. So let's generate some sample data set. In your instance, let's say when you work for a company, you would not be generating data set. You will be using your company's data set. So in this case, I'm just generating 1,000 samples right here, and I'm creating a Pandas data frame right here, and I'm generating two columns, feature one, feature two. So your feature one could be, let's say, age of a customer, and feature two could be maybe weight of a customer. This could be income. This could be anything of a customer. And target. I'm also creating a new column called target. Now my target is going to be binary, so it's going to have two values, 0 and 1. So in this case, this could be maybe a customer churns or not churns, or customer buys the product or does not buy the product. Could be anything. Okay, and then I'm creating the target, converting into integer, and I'm printing out the data set right here just to see a few records. You can see that it has feature one, feature two, and target. And then I split my data set into training and testing. So first thing I'm doing, I'm separating my X and separating my Y. My X will be my feature one and feature two. So these are my X right here. And my Y is what I'm trying to predict. That's my target. After that, I'm calling this inbuilt method train test split that actually splits my data set into training and testing. Testing would be 20%. And now I define my candidate models. So let's say I have two models, model A and model B. Model A is the previous one, the company that has been using so far. So let's say the company has been using random forest classifier with number of estimators A. So this is my old model that the company is using. And let's say I have a new model B that would be logistic model. So I put the models inside a dictionary right here, and this is where my result is going to get stored. Next step, I'm going to train and test and evaluate my models. So I'm going through each one of the models. Going through each one of the model right here. I'm training the models, and then I'm asking it to make a prediction on the test data set. Then I'm checking the accuracy and F1 score of the each one of these models, and I'm storing them inside the result. So inside the result, I have model, accuracy, and F1 score. Then I'm converting that into a data frame, and then I'm printing out the model performance right here just to see how the model is doing. And you can see that here, random forest accuracy is this, and F1 score is this. For logistic regression, this is the accuracy, and this is my F1 score. Next step, now I'm going to decide which model to deploy. So industry's practice is this: choose your model based on F1 or business metric. That's what you want to use. So in this case, let's say I'm using F1 score. I'm just choosing F1 score. You could be using any other metric. So in this case, by based on this my F1 score, I actually sort them, and then I look at the top model, like which model is doing the top. So in this case, my best model is logistic regression. So recommended model for deployment based on your F1 score is logistic regression. You can see that just by looking over here, logistic regression gave you a better F1 score. So that's how you're doing it. Next step, now you say mark for deployment. So you can actually use this model, the best model for deployment model. So at the end, I'm just writing this down, model ready for A-B testing, deployment.